Okay, here's question C. So this question is asking us about basically the standard deviation of player C. So I've got two players, and from here I'm going to draw out a distribution for each. So I'll start with player B. So player B, here's his distribution approximately, and we're told in the question that player B has a mean of 1496. So that's his mean, and we're also told that he has a standard deviation of 7.81. Okay, and then we've got player C. So player C, and he's got a mean of 1496 as well. So that's his mean, and his standard deviation, we don't know, that's what we're looking for. But we are told a little bit about player C. We're told that he will expect to burn more than 1500 calories 28% of the time. So in other words, that area there will be equal to 0.28. Okay, now just one little thing I'll note here is that if that area is 0.28, then this area here is going to be 0.22, and I'll explain why that's important in a minute. Okay, now we've got the mean, we've got an x value. What we need is the standard deviation. So this is an inverse problem, but not a calculator inverse problem, because a calculator inverse problem would be asking us for this thing here, x, which we've already got. So we can't use our calculator here. So the other tool that we've got is our formula sheet. So I'm just going to bring up a formula sheet here. So here we go. Here's a formula sheet. Let's have a closer look. And here's the normal distribution table on our formula sheet. Okay, so it's got this formula here, which is useful for us. We're going to use that in a second. We've already got x, that's 1500. We've already got the mean, that's 1496. So we need, and we want to work that out. So in order to work that out, we're going to need something for z. So a z value comes off our table here, and if we look at this diagram, it's showing that the table's working for that area in there, and that's what we worked out to be 0.22. So in this part of the table, we're looking for 0.22. So if we come along here, 0.22 is somewhere between these two numbers here. And if we look at our differences column, if we added 10 1,000ths, that would bring this number up to 0.22 exactly. And so we've got 0.58 to get to that number there, and then 3 to give us the extra 10 to bring it up to 0.22. So that number again is 0.583. So let's go back to our test and back to where we were. Here we are. And so what it was saying here is that our z value for this amount here, our z value would be 0.583. Okay, let's write out the formula then for z values. So that z equals x minus mu over sigma, which is standard deviation. So just worked out that z is 0.583, and the x we know from our diagram is 1500, our mean is 1496, and our standard deviation is what we're looking for, so we'll just leave that there. Okay, so let's times both sides by our standard deviation, so that gives us 4.583 equals, well, 1500 minus 1496 is 4, and I should have sigma there. So just to remind you what working I did there is I times both sides by sigma, and on this side the sigmas cancel out. Okay, so now our next step here is we're going to divide both sides by sigma, so not by sigma, by 0.583. So it cancels out on that side, and all we're left with is sigma. So we've got sigma equals, and then 4 divided by 0.83, we put that into a calculator, we get 6.861, and that's our standard deviation. Now if we go back to the question, it's asking us to compare the standard deviations. So if this is player B's standard deviation and player C's standard deviation is this, well, we can say that player B has a larger standard deviation. So let's write that down. So player B has a larger standard deviation of 7.81 compared to player C's standard deviation of 6.861. And so now we can just interpret this in context. So this means that means player C tends to be more consistent with his times. Okay, since the standard deviation is smaller. Alright, and that's question 1C.